Change is the only constant in life and in cloud architectures. And this is a great thing and very different to traditional architectures. You see, before the cloud, architectural decisions were often static. The architectures might experience one or two changes during its lifetime. And this approach often resulted in oversizing, overspending, and very little flexibility for experimentation and improvement. Fortunately, in the cloud, architectural decisions are often reversible, quickly and inexpensively. This opens up the possibility of experimenting often, building quickly, and evolving your architectures as your business changes. But having this sort of freedom on AWS means you can combine over 200 different services with their deep functionality in an almost infinite number of ways. And when you consider your options, you might realize decision-making might not be trivial. So my name is Gerardo, and today I'll have a go at helping you become more confident when evolving your cloud architectures. And I'm going to do this by taking one example web application through a few changes on a virtual whiteboard. It's the first time we do this in Summit. Let's see how it goes. Okay, so let's say that you've been made responsible for the quintessential enterprise monolith. It's comprised by an EC2 instance and an elastic IP address. Inside of it, you find some application code, some dependencies and binaries, some files, and some MySQL databases. So how would you improve this architecture? Well, if you're like me, you're having this burning desire to change everything now. But before you can start implementing your grandiose vision, something goes wrong. It turns out the application goes down. Someone in your team was upgrading the MySQL binaries, and they took down the application for 2 hours. So how can you prevent this from happening? Well, there are a few reliability improvements that we can make. The first one is I'm going to suggest that you or your team never implement untested changes in production. This should be a simple one. So instead, you can use something like CloudFormation to create a replica of your application for consistency. And then the tests that you run on non-production environments and are successful, then those changes are more likely to also work in production. Now, if you've never used CloudFormation before, one of the things that you're going to have to do is to automate the deployment of your application. And if you haven't chosen your tool of preference, I'm going to suggest that you keep it simple by using the user data section on the EC2 CloudFormation resource. This field allows you to write a bash script or a PowerShell script to do all the things that your application needs to be deployed, like installing libraries or dependencies, pulling files, loading your database, or pulling the latest version of your application code. Now, by testing in non-production environments, that already makes your application less likely to suffer from outages like it just happened. But what else we can improve from the reliability perspective to prevent outages? Well, I'm going to suggest that running MySQL on your instance can be actually more challenging than running it on a fit-for-purpose service like Amazon RDS. Among other things, RDS manages administration tasks such as, you guessed it, upgrading the database engine. So outages like this wouldn't happen if you were running something like Amazon RDS. So to prevent database engine upgrades to becoming an issue in the future, I'm going to introduce an instance of RDS. And for the sake of this example, I'm going to choose the Aurora engine, or at least the MySQL version of it. And I'll justify that in a second. Now, by offloading those MySQL tables to the database, we are improving our application, and we can also make it more cost-effective. I know that when you're introducing a new service, it comes with added cost, but you can actually downsize your instance after it no longer has to do all the processing for the database functionality. And it's also cost-effective when you account for the time and the effort of actually managing this thing yourself. Now, what other reliability improvement we can make in this architecture? Well, depending on how long you've been in the industry, you realize that this application has single points of failure everywhere. And this is contrary to one of the bedrock principles of architecting in the cloud. And so we're going to introduce high availability. So how do we do this to this application? First, I'm going to start on routing. How do you point traffic to the application? So instead of using an elastic IP address, I'm going to introduce an application load balancer. The application load balancers are one of those services that are regional by default, meaning that they are a logical construct that it's highly available and spans multiple availability zones. So there's no single point of failure there. We still have single point of failures in the rest of our components, but not on the load balancer. Once the load balancer is in place, you can create another instance for your application, and then the load balancer will start distributing traffic evenly to the instances because we offloaded the session state. This is a stateless application, as long as they remain healthy. This will ensure that your application stays available if there's an issue with one of the instances. Now, what about the database? We can also introduce high availability in the database. In the case of Aurora, it means creating an Aurora replica, which is a synchronous copy of the primary database in a different availability zone. Now, Aurora replicas, as opposed to standby instances on the normal RDS, have two purposes. The first purpose is for failover. Aurora detects an issue on one of the databases and fails over to the replica, which is similar to the standby instances on RDS. But the second purpose is that you can point reads to this replica, and that doesn't happen on RDS. So if you ask me, yes, while Aurora costs a little bit more than RDS, maybe 10%, but don't quote me on it, when you account for the availability improvements, the performance improvements, and the fact that you can point reads to the replica, I think it becomes a no-brainer to use Aurora for highly available applications. And as an added benefit of using Aurora, we can leverage something called Aurora Serverless, which automatically starts up, shuts down, and scales up and down as needed, and you only pay for the capacity that you use per second. Now, Aurora Serverless has many good use cases, like applications for bursty traffic or unpredictable traffic. But in our case, we can just simply leverage it for non-production environments to save some money, because it's going to shut down once you're not doing development or you're not doing running testing. Okay, so our applications is looking a lot more reliable. But I want to introduce one more component to this, and it's at the DNS level. And this is something called Route 53 Application Recovery Controller, or ARC. This is a new feature on Route 53 that allows you to, it'll actually become more useful if our application becomes multi-region one day, maybe wait 20 minutes. But for now, we can leverage something called zonal shift. In zonal shift is something that with a click of a button or an API call, it can shift traffic away from an availability zone temporarily. And this is very useful when you encounter an issue and you want it to stop more quickly. So this will become more useful later on. So this is good. Our application is looking a lot more reliable. Don't you agree? Now, as soon as you start feeling confident, your users start complaining about performance. This is just like in real life. Now, in order to fix any performance issues, the first thing you need to do is to actually understand what's going on. And Amazon CloudWatch is one of the services that includes a full stack of observability features, from metrics, alerts, logs, even things like internet diagnostics, and also synthetic monitoring with CloudWatch Synthetics. Synthetic monitoring is this kind of services that allows you to measure user experience by tracking the actions that a user would take on your APIs or your URLs. So let's say, for the sake of the example, that by using CloudWatch Synthetics, you notice that at times, response time gets into several seconds for media downloads for your users. So your users are right to complain. They have bad performance, and you've found at least the cause of it. I don't know if the cause, but one of the symptoms. So where is this media stored? Well, it turns out that we still haven't decoupled the media. The media is still sitting on our EC2 instances. And this is not a good thing to do for a couple of reasons. The first one is for storage. it becomes more expensive to store media on file systems as opposed to on a fit-for-purpose service like, Amazon S3. So we're going to actually put those files where they belong on S3. But the second reason it's not a good idea is for delivery. And this is where a content delivery network comes in, like Amazon CloudFront. In my mind, CDNs like CloudFront are no-brainers, again, because they do many things. First, they improve, they reduce cost because traffic out of CloudFront is more cost-effective than from S3 or EC2. It can also offload your instances from this functionality so you can downsize them and save some money. And it can improve the user experience because it's delivering from over 450 locations across the world. It also has reliability and security improvements I'm not even going to get to. So CloudFront, one of those no-brainers. So we're going to implement it here. And what we need to do is to point CloudFront to the two entry points of our application. For the media is on S3, and for your APIs and application is on the load balancer. Okay. So this should fix that first finding from CloudWatch Synthetics. But where else can performance issues come from? Some of you might be hurt by relational databases for decades. So they are a common bottleneck for performance issues. And a tool that I love to troubleshoot performance issues is Amazon DevOps Guru. DevOps Guru uses machine learning to detect and then alert on application performance issues. For RDS specifically, it finds things like log pileups, connection storms, SQL regression, CPU and memory contention issues, and other things. And so it becomes very useful. So for the sake of the example, let's say that DevOps Guru finds two issues. Oh, and by the way, one of the best things about DevOps Guru is that it recommends things you might consider to solve the performance issue. So for the sake of the example, let's say that the first finding is you have excessive reads on that session table. Now, what could be a performance-optimized solution for storing sessions? A common one is introducing a fast in-cache or in-memory cache, such as Redis. The flip side of that, of course, is that in-memory caches come at an added cost. But if users are complaining and DevOps Guru found the issue, we actually have to implement this. And so let's move these databases a bit down here. Yeah. And we're going to introduce a caching layer using Elastic Cache for Redis, which also comes in a multi-IC cluster across multiple availability zones. And it offers sub-millisecond latency. So performance out of those sessions shouldn't be an issue now. This fixed that first one. Now, the second thing that DevOps Guru found is that our Aurora cluster is encountering errors of the type of the too many connection type. And it recommends that we consider using RDS proxy. That's very specific from DevOps Guru. Thank you very much. So RDS proxy is a service that pools and shares database connections. So by pointing your application database connections to the proxy, it pools those and then distributes those to the database in a smarter way. And by doing this, your application will be able to scale and handle unpredictable searches of database traffic that would otherwise cause oversubscribing connection issues. And so this is a great recommendation from DevOps Guru, and in it goes. And so let's recap what we've done performance-wise. We offloaded the media from the instances into fit-for-purpose services, S3 and CloudFront. We also introduced caching in a performance-optimized way using Redis, and we've also introduced RDS proxy for improvement of the database scaling. Now, RDS proxy is also a regional service like the load balancer, so we don't need to worry about single points of failure there. So users are happy, at least for now. All right, a few months pass, and you find yourself talking to your CEO about sustainability, which is very topical these days. So you log onto the AWS console, into the customer Canvas footprint tool, and you say that your carbon emissions are actually stable. But a good question to ask is it stable good? Because in a business that has a defined peak of seasonality, maybe something like this, maybe stable is not good enough, and your CEO puts you on the spot saying, if the cloud is elastic, shouldn't our carbon emissions roughly track our seasonality? And she's got a point. And so what's going on here? Well, what's going on is our architecture has a few components that have elasticity built into it. We don't need to worry about those. Like CloudFront, like Route 53, the load balancer, RDS proxy, the S3 bucket, elastic by default. But there are others that are not elastic by default. The EC2 instances, the Elastic Edge cluster, and Amazon Aurora. So what happens is that these resources are currently oversized to cater for that seasonal peak, which means you're emitting carbon unnecessarily during off-peak season. Of course, you can downsize these things manually during off-peak season and then up during peak season, but we know that automation is the key to efficiency. It's a best practice in the cloud, and for the sake of the environment, we're going to automate this. So here's where it enters autoscaling. For EC2, autoscaling adds and removes instances dynamically to meet demand. But it's not something you can just enable by ticking a box. Your application needs to be prepared for it. And two of the things that your application needs to comply with is it needs to be stateless. And yours is, because we have loaded that session data first to the database and then to Elastic Edge. So tick. And another requirement for scaling is your application needs to be automatically deployed, which it is, because we did this when we implemented CloudFormation. So with this, we can just enable autoscaling, and it'll allow us to reduce the size of those instances to minimize carbon footprint during the off-peak season. And now, believe it or not, both Elastic Edge and Aurora have autoscaling functionality, which is not very common for databases, but they do. With Elastic Edge, it will dynamically add or remove replicas or shards based on a metric that we can configure, and this is something that we can more easily just enable. And with Amazon Aurora, it dynamically adds or removes replicas to our cluster. Okay, so we cannot make the primary node elastic, but we can make the replicas elastic. So it's still a win, and we're going to take it because it's going to allow us, again, to downsize those resources. So we downsize the resources so that autoscaling can do its thing during the peak time and scale them up when necessary, right? So what is the result of these changes? Well, the result is what we expected, something like this. So the carbon emissions are going to roughly track our business seasonality, and we are saving the environment from all these carbon emissions between the two curves. The planet is happy, your CEO is happy, and you're feeling great, don't you? As an added benefit of implementing autoscaling is we've improved resiliency, because autoscaling is also a self-healing mechanism. When it detects that something failed, it replaces that with a healthy instance. And you can put to the test this new resiliency by running chaos experiments using the AWS Fault Injection Simulator, which I have hidden here. Now, AWS FIS is the kind of service that lets you perform control experiments. Termination of resources, forcing failovers, stressing CPU or memory, packet loss, throttling, and many other nightmares. And I know this might sound scary if you've never done chaos engineering before, but you can get started in non-production environments to get familiar with it. This is what it takes, resiliency from theory to reality. It will allow you to gain confidence that the resiliency mechanisms that you put in your design will actually work in the case of a real fault. And if chaos engineering doesn't make you uncomfortable, ooh, I'm having some technical issues here. Okay, how about a security event? So you find that your developers are accessing user credentials from the database. But this is, let's not make any judgments. Who here has seen security credentials stored on a database in plain text? Many of you? Yeah. Well, not so many of you, but I have. And it's common. And of course, you can do this thing securely. You can store the credentials securely by using things like salt hashing for storing them. And you can use something like secure remote password protocol to manage the handling of those credentials of the wire. But the most important question in my mind is, why would you? It is a security best practice to use a centralized identity provider like Amazon Cognito, because you are offloading not only the authentication, but you're offloading the storage of those credentials. It'll save you the time and the worry of actually doing this. And it can also save you money because you're offloading your instance from doing that functionality. And so we're going to introduce Amazon Cognito user pools, which is an identity store for your web users that scales to millions of users. And as a result of moving that user store to Cognito, again, you're saving time, worry, effort, and you've made your application more secure. Okay. All right. So let's say, and this is the last story, let's say that your company has raised some capital, they want to expand to Europe, and you are in charge of making sure that your European users have decent performance. So far, you've been serving your users from one of the two fully fledged regions we have in Australia, either Sydney or Melbourne. I'm going to choose Sydney for the sake of the example. And while you've implemented CloudFront, and it certainly helps speed up the delivery for your European users, sometimes CDNs are not enough. In cases where you have lots of API activity or large geographical distances, or you have a lot of dynamic content, you may need to actually go multi-region and deploy resources closer to your users. For example, in Ireland, if we want to serve those European users. So how would you approach actually going multi-region? This is not I don't want to pretend this is a simple topic, but I do want to suggest we start simple by considering the AWS services that have built-in multi-region functionality. So let's go through each of the components. And first, let me move this Route 53 here because it's a global service. Okay, let's start with your databases. Let's think about those MySQL databases. Some of those databases, like let's say local inventory, might make sense to be recreated in Ireland and be run independently for local inventory in that region. But some others make sense to remain global and centralized, like global sales numbers. And for that, we can use something called Aurora Global Database, which is a service that allows Aurora to span multiple regions by creating replicas in secondary regions with a typical latency of less than a second. So pretty fast. Now, Global Database also has features like you can point rights to Ireland, to your replica in Ireland, and it will forward those to the Sydney region. And it can also let you test failover by clicking a button or an API call. It can switch the primary cluster to Ireland while keeping the replication topology intact. Pretty useful. So what about S3? For S3 supports something called S3 replication. That's an easy one to remember. And what it does is that it keeps objects in buckets in sync across multiple regions. S3 also offers something called S3, and this is going to be a big acronym, multi-region access point, which is a global construct where you point your applications to, and it routes those to the S3 region with the least latency, and it also helps you do failover as well. So it simplifies. Again, multi-region is not necessarily the easiest topic, but when you use these constructs, it makes it easy for you. Okay, what's next? Elastic cache. With Elastic cache, it depends on what we're caching, but in our case, we stored some sessions there, and you might want to let your users add items to the shopping cart in Sydney, and then there's an issue, and you fail over to Ireland, and you want them to just check out. You don't want them to lose their session. In those cases, you can leverage something called Global Data Store for Redis, for Elastic Cache in Redis. And what it does is very similar to Aurora, which it basically creates replicas in secondary regions. Depending on your use case, it might work for you. Then there's Cognito. For Cognito, we can just create a new user pool for storing those European users. And in case you have Australians going on holiday to Europe, you can create some retry logic in your application that checks that secondary user pool if the users are not on the first one. And with the rest of the components, the CloudFront distribution, the application load balancer, RDS proxy, and your instances, those are resources that simply you can just recreate using CloudFormation because they just contain configuration files. All right, and finally, there's routing. You can create a latency routing policy to point your users to the region with the least latency for them. But remember that we actually implemented Arc. Now it's going to become very useful because it can give you insight as to whether your application is ready for failover. And again, click of a button or API call, it lets you do the failover itself. So it makes it easy to do failover at the DNS level. So what did we do? We expanded multi-region to improve the performance of our users in Europe. And we also expanded our options for achieving extreme reliability. Okay, I'm doing well on time. Great. All right, so what have we done? We have gone from technical glitches. Okay, we have gone from this monolith to this globally distributed application. So I want to take this opportunity to tackle one of the elephants in the room and make it our first takeaway. Are monoliths simpler, and as a result, distributed applications more complex? Well, like anything in our industry, it depends. If you just want to keep the lights on an application, and if efficiency doesn't matter as much, if you're not continuously releasing features, and if you have sort of predictable traffic for the application, okay, maybe a monolith will do. But if you want to build modern applications, if you want to continually improve your customer experience, release features often, if you want to maximize scalability, flexibility, and you can tell that I'm a bit biased, then distributed applications are your friend. The second takeaway, if the whiteboard lets me, or maybe not. Okay, the second takeaway is decoupling is a best practice of architecting in the cloud. You saw how decoupling helped us improve resiliency when we offloaded those MySQL components. You saw how it improved performance and cost when we use fit-for-purpose services for the media files into S3 and CloudFront. And you saw how decoupling improved our security when we use a centralized identity store for our users. There you go. So decoupling all the things is a best practice for cloud architecture. Third takeaway. Cost is not the only reason elasticity is a good thing to architect for in the cloud. The environment can actually thank you for it. You saw how it actually reduced the carbon emissions of our application. And finally, while I'm not pretending that multi-region is an easy topic, I want to suggest that you start by considering the AWS services that you offer multi-region as a service, or that have the built-in functionality for multi-region. So let's go back to my slides, please. And so I want to invite you to embrace change in your architectures and take advantage of the reversible and inexpensive nature of experimenting in AWS. So if you want to learn more, you can visit skillbuilder.aws. Thank you for being here. Please rate that session. First time we do live whiteboarding. Did it work? Let us know. Have a good rest of AWS Summit.